Hello everyone. So today we will be discussing about Internet Protocol version 6. In previous lecture we have discussed about Internet Protocol version 4. So now we have IPv6. IPv6 is the most recent version of Internet Protocol, the protocol that provides an identification and location system for computers on network and routes traffic across the internet. So IPv6 is the advanced version of IPv4, and the work of IPv6 is similar as IPv4. Then why we need IPv6 or IPv4? Because IPv4 does not provide any security for data which we are transmitting through internet. So, and the data prioritization in IPv4 is not up to date. So these are the things. So we need IPv6 over IPv4. Now these are the features of IPv6. It has larger address space. Having larger address space gives us more combination of addresses, and it has simplified header. So simplified header can move all the unnecessary information and options which are present in IPv4 header. So it has end-to-end connectivity, so it can traverse through the internet without using network address translation, and it has auto configuration. It has faster routing. So all the information in first part of the header are adequate for a router to take routing decision. And it has IP security, the most important thing, security. And it does not support broadcast, and it has one feature, that is Unicast, and it supports the mobility. This feature enables host to roam around in different geographical area and remain connected with the same IP address. And it has enhanced priority support. It has smooth transition and extensibility. So these are the features of IPv6. Now what is the header structure for IPv6? So here we can see the structure of header of IPv6. It has version of 4 bits, and the priority class is of 8 bit, and the source address it contains is of 128 bits. So these are the components that are present in its header structure: version, traffic flags, and the payload length. Payload length, it is a 16-bit field, indicates total size of the payload, which tells router about amount of information and a particular packet it contains in its payload. Now next, it has next header, hope limits, source address. In IPv6 the source address is of 128 bit, and the destination address is also has 128 bit, and it in addition it has extension header. So this is the extra field of in IPv6. The extension header mechanism is very important and part of the IPv6 architecture. So next header field of IPv6, fixed header, points to the first extension header, and this first extension header points to the second extension header, and so on. Now what is the address format of IPv6? Because it has 128 bit address. So before introducing IPv6 address format, we will see the hexadecimal number system that used to represent the values in readable form. So these are the numbers presented in decimal form, binary form, and hexadecimal form. Now, IPv6 address is made of 128 bits divided into 8 16-bit blocks. Each block is then converted into 4-digit hexadecimal numbers separated by colon symbol. So this is the example we can see here that this is a 128-bit address and it is divided into 16 blocks, and each sorry, it is divided into 8 blocks and each block contains 16 bits. So this is the address of 128-bit in IPv6, and this is separated by colon. So even after converting into hexadecimal format, IPv6 address remains long. IPv6 provides some rules to shorten the address. The rules are as follows. Now the first rule is discard the leading zeros. Now in block 5 there is 0063. So in block 5 0063 the leading two zeros can be omitted, such as fifth block. So we have omitted the 00 and we have only 63 here. So this is the method to shorten the address. Now rule number 2, if two or more blocks contains consecutive zeros, omit them all and replace with double colon sign, such as 6 and 7. Here in 6 and 7 block we can see there is only 0. So we can omit all the zeros and put the double semicolon sign. So we have omitted the 0 and put the colon sign here. So this is another method to shorten the address. And consecutive blocks of zeros can be replaced only once by double colon. So if there are still blocks of zeros in the address, they can be shrunk down to single zero, such as second block. Now we have zeros in second block also. So in this, for the second block we will put 10 for the 4-digit. So this is the method to shorten the address. Now addressing modes of IPv6. So there are 3 addressing modes in IPv6. First is Unicast. In Unicast addressing mode, IPv6 interface is uniquely identified in a network segment, and the IPv6 packet contains both source and destination IP address. A host interface is equipped with an IP address which is unique in that network segment. A network switch or router, when receives a unicast IP packet destined to single host, sends out one of its outgoing interface which connects to the particular host. So this is the unicast addressing mode where it sends the information only to a particular host. This is the multicast mode. In the multicast mode is same as the IPv4. The packet destined to multiple hosts is sent on a special multicast addresses. All the hosts interested in that multicast information need to join the multicast group first, and then it is sent to all the hosts which are joined. Now it has Unicast. In Unicast addressing mode, this is the new type of addressing mode introduced in IPv6. In this addressing mode, multiple interfaces are assigned same Unicast IP address. When a host wishes to communicate with a host equipped with an Unicast IP address sends a Unicast message. With the help of complex routing mechanism, that Unicast message is delivered to the host closest to the sender it in terms of routing cost. So this is the three different types of addressing modes in of IPv4.